I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to discuss few questions based on kinematics and dynamics. These questions have been selected by my student Amy. We'll explore the application of these formulas v equals to u plus at, s equals to ut plus half at square, v square minus u square equals to 2as to solve the kinematics questions. And then we have a very important question based on dynamics where we'll apply the principles of F equals to ma. Let us connect with what we know to where we want to go. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us enjoy the session with Emmy. Hi, Emmy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good, very good. So today, what do you want to learn?
It's a bit of a it's part of maths which I'm not really a fan of. It's not the pure side. It's more mechanicsy physics kind of thing. It's like kinematics and like forces in general and suvat. So ball going up, ball going down, pulleys, stuff like that. So yeah, do you think we
Okay.
could focus on that today?
Sure. Why don't you share and then let's see.
Okay. Let me just get that up. Okay, so I have a couple questions. I just kind of took a couple pages from my book because I think roughly. Should I go over the questions I actually didn't get or just in the order that I've kind of printed it?
No. You can go with the questions which you don't get and we can look into those questions, right?
Okay.
No problem.
So I just have to find it. Okay, so can we start with 12?
Sure.
We just go out there?
Yeah,
All right.
please read the question.
So a ball A is thrown vertically downwards with the speed 5 meters per second from the top of a tower block, which is 46 meters above the ground. At the same time as A is thrown downwards, another ball B is thrown vertically upwards from the ground with a speed of 18 meters per second. Mm-hmm. So the balls then collide. Find the distance of the point where A and B collide from the point where A was thrown.
Okay, so it is very important to sketch the scenario first, right?
Right.
And then understand what is going on here because these questions, they are actually very tricky. So unless and until you have a very clear sketch, it may not be easy to figure out, right? So we are looking at two positions. One is the top and one is the bottom. Let's say the ground position is right there. And the ball is being thrown, that means with some velocity, right? So
yeah,
ball A, let's say this is ball A, which is thrown vertically downwards with a speed of 5 meters per second, right? So let's say velocity here is, I should not say here, initial velocity V0 for this ball is 5 meters per second. Is it clear?
So V is 5.
Initial velocity with which it is thrown down, right?
Also, U is 5.
U is 5. Yeah. When I write V0, it means U. Okay, U is 5. Let me clear this. It's easy to use your.
Sorry, I just do the suvat thing. Yeah, that's fine.
It's
Thanks.
easy to use that, right? So okay, that's fine. So at this stage, we know U is equal to 5 meters per second. And let me write A for ball A. Is it okay?
Yeah.
5 meters per second from the top of a tower block, which is 46 meters above the ground. So total height is 46 meters. At the same time, as a ball is thrown downwards, another ball B is thrown vertically upwards from the ground with a velocity of 18 meters per second, right? So we have another velocity given to us as 18 meters per second, where it is thrown upwards.
Mm-hmm.
The ball collides. Find the distance of the point where A and B collide from the point where A was thrown, right? So let us assume that they collide somewhere in between, right? So let's say they collide in this position. Correct? And we have to find the distance of the point from above, right? So let's say this distance is D. Which we need to find, right?
Yeah.
Okay. So basically, they cover the same distance during the time which we are talking about. Is that okay?
Yeah.
So let us say that the time taken is T. T is the time taken.
So are we only dealing with ball A?
Both balls, A and B, right? So at the same time,
Oh.
they are at the same
Colliding.
height from, let's say, top or bottom, you can consider, right? So if that is D, then the ball B has traveled a distance of 46 minus D, right?
Okay, so T is the time where both balls are at the same height.
Yes, T is the time when both the balls are at the same height. So
Okay.
basically, you have to find an expression for the height of the ball at any instance of time, both of them, and equate them. Is that clear to you?
Okay.
So when you're throwing the ball down and you have the value of G is given to you, which adds to this velocity, so half gt squared and ut, right? So you can find S, this, you can use the formula, S equals to ut plus half gt.
Half AT squared.
AT.
Is this for ball A?
So you could use both the formulas. The only thing is now the convention. So the gravity is acting downwards, correct?
Mm-hmm.
Gravity is acting downwards. And for ball A, velocity is also downwards. Does it make sense to you? Both are downwards. So it will be positive for both. Is that clear to you? If you consider downward to be positive, because it will speed up, the velocity is going to increase as the acceleration due to gravity is going to pull it down. The ball which is thrown upwards, the velocity is decreasing. You get the idea?
Yeah, yeah.
So in the first case, the displacement S is D, right? So for case A, let me write down case A here. Ball A. So in that case, if you use this particular formula, then you know the initial velocity, and we are looking at a distance which is D, right? That distance is equals to 5t plus half, and gravitational force, you're taking 9.8, right? T squared. So that becomes the distance traveled by the first ball in the given time.
Right.
Now, if you consider the ball B.
Wait, so should we simplify it or no?
Yeah, you can simplify. You simplify.
4.9 T squared.
Right. Yeah, that is all. Yeah, you can do that. No problem.
Okay.
Let it be so. Yeah, we can write 4.9. That's good. Now, the other ball, which is going upwards, the distance traveled by the other ball is 46 minus D, right?
Oh yeah. But now this time, are we taking upwards as positive? Always.
We are treating this as a separate equation. Don't worry. We'll just equate the distances to the same. Distance is positive always, right? 46 minus d, right? Equals to initial velocity. If I take upward velocity as my initial velocity, which is 18, right? 18t. Now, for this, acting downwards is the gravitational force. So minus half of gt squared. Does it make sense to you? So I have taken in this case, upward velocity is positive. So I'm saying upward is positive for this case. Distance, remember, is a scalar quantity. So we are just comparing.
Is S displacement though?
Yeah, that's okay. We are taking the absolute value of that.
Oh, okay.
We are only, because we know direction is up or down, right? So the vector quantity is only up or down. So it is displacement because it is moving up, correct?
Yeah.
The other one is displacement moving down. However, we are looking into the magnitude of it, right?
But just a quick thing, sir. So with bowl A, we took the downward as positive, but then with bowl B, are we taking upwards as positive?
Yeah, treat that, doesn't matter. Just treat them as two independent systems.
Okay.
Yeah.
Because I keep doing this whole upwards and down because the signs keep switching like before, like when I do later on questions. So I'm always like trying to see which one is upward is like positive or negative, so that because I always get the signs wrong. So is there any way to avoid
that? The problem here is when we put too many negatives together, I know negative becomes positive. It becomes very confusing.
Yeah.
So we are looking at the question like this. Our first part of the question is that during the time t, what is the distance traveled by ball A? One question.
Yeah.
Second, during the same time t, what is the distance traveled by ball B? Sum of these two distances, 46, we could do like this also.
Oh, yeah. In that case, you wouldn't be doing upward or downward. You just do.
Yeah, I mean, why should I? Yeah, I should use my convention to my advantage rather than getting bound with some difficulties.
Oh, okay.
I believe in that, right? Of course, the convention is very straightforward. Everything going up is positive and coming down is negative, right?
Yeah.
If I put all negatives, negative will cancel in the first equation. You get the idea, right? Negative S and negative U and negative T all will cancel to become positive equation as I have.
Right. And it's minus 9.8 for the second one because gravity acts downward, but we're going up.
Correct. So we are going up. Okay. I could have changed that to, you understand. But we are really interested in the magnitude. Is it okay?
Yeah. So absolute value.
Absolute value. So let's be very clear. We are just talking about this as a magnitude. This distance, right? Okay. So this is what we get. And or we could also say D1 and D2. Now, if we add them up, these two equations, this is my equation 1. You can see, right? Equation 1.
Yeah.
And this is my equation 2. And I add equation 1 plus equation 2. What happens? D and D will cancel because they are at the same height and I get 46 there, right? Or you could interpret this as the total distance covered is 46 by both the balls.
Oh, yeah.
So what we get here is 46 equals to, just add them up. 5t and 18t will give you what? 23t?
Yeah. And then that cancels.
And then half t square minus half t square cancels?
Yeah.
And therefore, I get 46 over 23 as equal to t, which is 2 seconds. Is that clear? Don't you think this is a very simple approach to this question? Rather than sticking on some book rules. Book rules are there to help your problem solution, not to complicate them.
Yes, to make problems. Yeah, that's why I had issues because because what we were taught in class was when you like have a direction as positive, the moment you have other variables, like in this case in bowl B, you can't just say now upward is positive now. Either all of it's downward or all of it's upward. But then when I kept doing that, I was like, the signs are switching, I'm getting confused. So this would make so much sense because anyway the distances add up to 46. So you might as well take the absolute value and then
Got
work
it.
through it.
We are looking into distance, which is absolute value. Total distance
Yeah.
is 6. Up and down is just a convention. You can always make it as per your wish. So what we have done basically,
Oh.
we have broken the question into 2 parts. We are looking at individual, and we are saying convention for part A is this and convention for part B is that.
Right.
How does it matter? We have got 2 independent equations which follow a rule, right?
Yeah.
And more than that, what we are looking into, total distance we are talking about, which is
Yeah.
total vertical distance, right?
Yeah. So 46.
That is absolute value, right? Absolute value of D is, I should write S, is 46. We are looking in absolute terms, which is a scalar quantity. Magnitude we are looking at, right? Up and whether this collided going down, that collided going up is not a question.
Mm.
So why are we complicating it? So
Yeah.
Now what is the question for you? The ball
Find
point.
the distance.
Find the distance of the point where A, from A you have to find. That means D you have to find. Plug
Yeah,
in
so
two
sub
the
in
first
D
equation.
into equation 1 and solve.
Equation 1. So D equals to 5 times 2 plus 4.9 times 2 square, right? Calculate. Write down in meters.
29.6 meters.
6 meters. Does it make sense to you?
Yeah, that's clear.
Absolutely clear, right? So
Yeah.
let's look at the diagram. Explain. You can always explain what I have explained you, right? Right? Or you could say total distance traveled is 46. I wrote D and 46 minus D, right? You can say D1 and D2, right?
Oh, yeah.
And then you can say D1 plus D2 is 46, right? Just add them up. D1 plus D2, right?
It's 46, yeah.
46. And
Oh.
upward, downward, if you start doing, then it's very difficult, right? Because
Yeah, that's why I didn't get anywhere. Because I was getting confused and I was getting it wrong.
You have a convention going up is, let us say, positive, then you say D2 minus D1. You get my point. D2
that's what I did.
I mean, it's too complicated. Yeah, let's forget about it, right?
Yeah. All right.
Convention
That's really clear, sir. Yeah.
should be used in our advantage, not disadvantage. Correct? So break your problem in a way that you understand how to solve it. That is what is more important. Correct?
Yeah.
So we've done this part, right?
So the
clear the
oh yeah, you can
okay.
Clear the screen. Yeah.
Next.
Yeah, could we do 13 as well? Only because it's the rebound one. And I've seen multiple questions where I've struggled with that. So if I get the concept here, I can maybe do the other ones myself.
Correct. Question 13. Can you please read it?
Yeah, so a ball is released from rest at a point which is 10 meters above a wooden floor. Each time the ball strikes the floor, it rebounds with 3/4 of the speed with which it strikes the floor. Find the greatest height above the floor reached by the ball. So, that's the
A
question.
ball is released from rest at a point that is 10 meters above the wooden floor. Right? So this distance is given to us as 10 meters.
Yeah.
Released from rest, U equals to 0. Each time the ball strikes the floor, it rebounds with 3/4 of the speed with which it strikes the floor. So if V is the velocity here, okay, let's say V1, first strike, correct?
Yeah.
So when it rebounds, in that case, V2 is equal to 3/4 of V1.
Yeah.
It says, each time the ball strikes the floor, it rebounds with 3/4 of the speed with which it strikes the floor.
Right.
Find the greatest height above the floor reached by the ball the first time it rebounds from the floor. So that means now, then it is not going with the same velocity, right? That means there is a loss of energy at this point.
The second time?
Yeah. First time and second time, every time, right? So since it is going up with this velocity, I'll assume that it will go, let us say, some distance, right? Not 10 meters for sure.
Yeah.
And then drop. Is that clear to you? We have to find this distance reached by the ball, correct? Now,
But
in
on the
this
first bounce,
yeah,
it will be less than 10 as well, right?
yes, yes.
Okay.
Now, first thing is we have to find the velocity with which it hits the ground, right?
Yeah. So,
So,
Suva.
right? So, which formula will you use? You know, u equals to 0. We need to find velocity, right? We are calling this velocity as v1, and s is 10 meters, and g is 9.8.
9.8. So we will use v squared equals
V
u
square
squared
minus u
plus
square equals
2as.
correct. So, yes, you are right. So, v square minus u square equals to 2as.
So when we're doing this, just I know you don't want to do, in this case, well, we're just saying downward is positive. So everything's all going to be positive values.
Okay. So we have to find v square. Let's put v square as equals to u square plus 2as, right?
Yeah.
When the ball is coming downwards, right? Now, when the ball is coming downwards, I will assume downward as my positive.
Okay. So in whatever the direction the ball is moving, just take that as positive. That's as simple as that. Yeah.
Better for you.
Okay. Yeah, because some teacher at school, they're saying when it's throwing up, you say down is positive. And I'm like, wait, that doesn't make sense. If it's going up, just
go
take
with the
up.
ball. Because see, gravity is constant.
Yeah.
You see, you cannot, gravity is always downward.
Right.
When you say ball is going down, down is positive for me, gravity is acting with it, velocity is increasing.
Yeah, that makes sense. Right?
Yeah.
Yeah.
So our convention here, equation is telling us absolutely right things, and that is u square. So u square, we are acting downward. So we are saying downward is positive for us. Is that clear to you? Yeah. Okay. So u is 0 plus 2 times 9.8, and the distance is 10. And therefore, we have what?
196.
196 meters per sec. Sorry, v square. So
no,
I'll
no.
do square root.
Yeah. And then square root. You get 14 meters per second.
Yeah. 14 meters per second. Right. There's a delay in this. Is that clear to you?
Yeah.
So we know V1 is 14 meters per second, correct? Now, yeah. So we know V1. Now we have to see what is V2. Again, we have to say case 2, right? So this is, we are doing case 1, downward, right? Now case 2.
So we just do 3/4 of 14.
First bounce. First bounce. You get the idea?
Oh, yeah.
Now, when the first bounce is taking place, then my U value is becoming what? 3/4 of V1, right?
Yeah, which is 10.5.
Which is 14. Okay. 3/4 of 14, correct?
Yeah.
So you are saying 10.5. Okay.
I just use a calculator. Yeah.
Okay. 10.5 meters.
So that becomes our U.
That becomes our U. So I wrote U, right? You see that? I wrote U.
Yeah.
Right? Now, my convention is velocity upgoing is positive for me, right? You get my point.
Yeah, it's going up.
Gravity is negative now because the ball is going up, right?
Yeah.
So, again, I have to now find the height, right? So, S equals to ut plus half gt square is a good formula to use, right? Or what? V square minus u square. At the end, final velocity will be 0. So, v square minus u square is again a good formula.
Oh, so for the greatest height we reach, the v has to equal 0.
Yeah, because then otherwise it could have gone even further up, right? So v square minus u square is 2as. I am again using the same formula. So we have v square minus u square equals to 2as. That is the formula I am using. And in this, v is 0, u is given to me. So it is 3/4. So let me do the calculations here, right? 3/4, you do the calculations. Which is 10.4. I can write 10.5. You calculate decimal value. That's good. Normally, I don't do these calculations. 10.5 whole square, right? Yeah. Minus. Because now I'm going with upward as positive, right? So, yeah. Minus. And this A is negative because A is acting downwards. Does it make sense to you?
So A is acting downward.
So it is negative.
Yeah. Why
And
is
now,
10.5 negative?
so minus V square minus U square formula.
Oh, you just
Oh, that's in the
moved it.
formula. No, that's in the formula. The formula is V squared. This is your SUA formula.
V squared equals U squared plus 2AS.
Oh, you may write like this. Yeah, U square on that side. So you are saying V square equals to
Oh,
U
I
squared
see what you
plus
did. Yes.
I know.
Yeah.
I'm used to writing it like this.
Oh, right. That's where the minus come from, but it's in the formula. Got it.
It is
Okay,
in the
cool.
formula. Is it okay?
Cool. Yeah.
Now S is clearly 10.5 whole square divided by 2 times 9.8. Is it okay?
Yeah.
Calculate. Tell me what is it.
S equals that divided by 5.625 meters.
Correct. So that becomes the height. So let me just calculate 2.5 whole square equals to divided by, and then, oh, wait. 10.5 whole square equals to divided by 2 times 9.8 within brackets. 5.625 is correct. So that is the height reached. Is that clear to you?
For the first time it rebounds.
Yeah. So we have answered the first time. For the first time, it rebounds from the flow, right? Find the greatest height. So greatest height is 5.625.
Yeah. So the main question was, so if you take, like, initially when we started off the thing, we said downward was positive, right? And that's because it was going down. But then when we went up, we said upward is positive. So it's fine to switch the thing around. You don't, just because you said downward from the beginning doesn't mean it has to stay downward, even if it goes up again. Okay.
No.
That was the rebound issue for me. Yeah, because it keeps changing when it rebounds.
Yes, convention. My convention is that the movement is positive.
Yeah.
So the movement of the ball is positive. I look at when you throw the ball, you look at the ball, man.
Yeah.
Whether you throwing it up, down, east, or west.
Yeah.
So that is how I look at the question, and it is not wrong.
Yeah, so movement is positive.
Movement is positive, right? And it's a convention, right? Agreed. Based on that, we are deciding all other things.
Yeah.
Correct. Now, second part. The second time it rebounds. Now you have to repeat the same thing, right? Now you know that.
3/4.
Yeah. Now you know the height, which was known to you earlier as 10, correct?
Yeah.
And then you have to do this part and get to V1 and 3/4 of that and repeat. So case 2.
So I think I can do that now. I've applied everything you said, and I'll redo it. All I know is that the height would be less than 5.625, right?
So case 3 and 4. So you do first case 3 to figure out with which velocity it is going to hit this time, and then you do case 4 with finding the distance height reached that time.
Perfect. Okay.
And what I will suggest at this stage, this is a common problem. So if you do not substitute the value, you will get a general expression of how does the height change with every rebound. You get the idea? Geometric progression.
Oh, so it should be going less and less because when you do a ball,
right?
Yeah.
So depending it by a factor 3/4, which they have said, right? So it is 25% is lost. You get the idea?
Yeah.
So that should actually give you a general formula. Also, you should look into that also. Is it?
Oh, that's cool. Yeah, I didn't think about that.
Yeah.
So when you take the values, would they be going down by like 0.25?
They'll be related. Yeah, related with that.
Oh, that's a good check. Okay.
Yes. So you can look into it. Is that okay?
Yeah.
So let me clear this, and because you see the pattern is being followed, correct? So if I just write velocity 1 as 3/4 of, velocity 2 as 3/4 of velocity 1, and then work it out, and do not place the values there, correct? Then you will see that.
Oh, I see. Yeah. That's clear. Okay.
Okay.
Yeah, so for some reason I'm having issues with, the normal like graphs,
Okay, let's look
yeah,
into the
question 16.
16. Okay. Can you please read the question?
Yeah, so when a car is being driven on a straight stretch of motorway at a constant velocity of 34 meters per second, when it passes a velocity restriction sign S, warning of roadworks ahead and requiring speeds to be reduced to 22. The driver continues at her velocity for 2 seconds after passing S. She then reduces her velocity to 22 with a constant deceleration and continues at the lower velocity. So draw a velocity time graph to illustrate the motion of the car. Yeah.
Correct. And find the shortest distance before the road work that she should be placed on the road to ensure that a car driven in this way has had its velocity reduced to 22 meters per second by the time it reaches the start of the road work. Great. Okay. So, a car is being driven on a straight stretch of motorway at a constant velocity of 34 meters per second. When it passes a velocity restriction sign S, warning, or the road, okay, so let's say this is the warning signal, S, warning of the road work ahead, and requires speeds to be reduced to 22 meters per second. So we want final velocity as 22 meters per second. The driver continues to her velocity for 2 seconds after passing S. She then reduces her velocity to 22 meters per second with constant deceleration of 3 meters per second and continues at a lower velocity.
So is the gradient of a velocity time graph is acceleration, right?
Yes.
So we need to make that 3.
Correct.
Mhm.
So
So
we are talking about displacement,
velocity and time.
the velocity and displacement is with time, right? So for now, we'll just put this as 34 for 2 seconds. So it says, and requires the speed to be reduced. The driver continues at her speed of for 2 seconds. So for 2 seconds, it is still 34. Is that clear?
Yeah. So 2.
All right, 2 seconds. She then reduces her velocity to 22 meters per second with a constant deceleration of 3 meters per second squared. Right. So then it reduces to 22. So at this time, acceleration is given to us as minus 3 meters per second.
Wait, so
Yes.
it says when she passes the restriction sign, she continues at her velocity for 2 seconds. Is that where we're starting the graph from?
Yes. That origin is the S symbol.
Oh, that's what I was gonna ask. Where's the S? Okay, cool.
That origin is that the S position. So now, final v square minus u square is 2as, right?
Yeah.
V equals to u plus at. So these are your formula which you could use. So look into all the formula which you have.
Yeah. V equals u plus at.
Correct? Then you have v squared minus u squared equals to 2as. These two can help you, right? Because you know the final and the initial velocities. Correct? You also now, and the other formula which you have is S equals to ut plus half at
squared. Then there's vt minus half at squared.
Huh?
S equals vt minus half at squared. That's 1, right?
Yeah. That is related with this. Correct.
Oh, okay.
Minus half at. Correct. So now these are your formulas. So in this particular question, as you can see, the diagram has been drawn. Now what are they asking for?
They're
Draw a
asking
velocity diagram to illustrate the motion of the car after it passes S. Find the shortest distance before the road work that S should be placed on the road to ensure that a car driven in this way has had a velocity reduced to this. So we have to find this distance, this point P. You understand? So
Wait, I didn't get that. I don't understand what they're asking.
So the thing is, when you see, for example, imagine like you see a sign, correct? It takes time to react. And that time, reaction time is 2 seconds for you.
Okay.
So, and then immediately you apply brakes. That is the deceleration process, right?
Yeah.
You will not jam it, right? You will do it gradually. So that is constant acceleration, correct?
Yeah.
And therefore, with constant acceleration, the car is going to take some time to reduce the speed from 34 to 22.
Yeah.
During this time, two things change. One is time, of course. The other thing is distance. You covered some distance, correct?
Oh,
the question really wants you to figure out how much distance was covered in this duration. And that is the minimum distance from where the speed limit of 22 should start so that nobody gets a ticket.
All right. Okay. Yeah.
So
that's so clear when you explained it like that. Yeah.
Yeah. So now we have all these formulae with us, right? Now we can find S also because we have this formula that velocity initial and final is given with A and T. So we know the time taken to do all this, right? So the very first formula, which is V. So it is good to have your formula ready. So we'll use the formula V equals to U plus 8. Is that clear to you?
Okay.
So final velocity is 22.
Initial is
34. Acceleration is minus 3 t
times t.
So 3t equals to 34 minus 22, which is 12 for you. And so t is equals to 12 over 3, which is 4 seconds. So you found, if you are plotting on this, then you have found that the time taken is 4 seconds, correct? Now this time is taken from the instance you applied the brakes, right? So this is 4 seconds. So 2 plus 4 is 6. You get the idea.
Oh, so 4. I thought the whole thing was 4. No. So 4 seconds is from the 2.
Yeah,
after you recognize the sign.
When the initial deceleration was applied, the brakes.
I see.
So 3 to 4. That means now within this 4 seconds, first you know the velocity, right? So you know in 2 seconds what distance will be covered, right? So in 2, now let's work distances, correct? So S1 is the distance covered in the first 2 seconds, which is with the velocity of 34, right? So 34 times 2 will give you 68 meters. Is that clear to you?
Oh yeah, I forgot. The area under the graph is a distance.
Yeah, area under the graph is a distance.
I thought you were going to use another formula. I was like, that's going to be long. Okay.
I use the formula S equals to VT.
Oh, right. Okay.
There's a constant velocity, right? And rectangle, you're correct. What you are saying is that this is your distance, correct? Very good.
I thought that's what you did. Yeah.
I love that. Actually, that's a good idea. I did not do that though. I use the formula. And this area also you can find. You get the idea?
Yeah.
Anyway, so, and then S equals to ut plus half AD squared is your v square minus u square is 2as will be a good formula to use for the second distance. Is it okay?
Yeah. So is this to find S2? Also.
So we know the final velocity is 22.
Is this S2?
Yeah, S2. So final
which
velocity
is between 2 and 6.
Correct. And the initial velocity 34 equals to 2 times acceleration minus 3, and I'm writing S2, the second distance. Is that clear?
Yeah.
And this you can calculate. Use calculator. 34 square minus 22 square divided by 6.
So 24 squared minus.
Not 24, 34.
Oh, sorry, 22 squared
Okay.
minus 34 squared minus 672, and then you're getting minus 6s. So minuses cancel, so 672 divided by 6. 112?
112.
Yeah, 112.
So this distance S2, so we know this distance S1 is 68 meters, and this distance S2 is 112 meters. So the total distance S is S1 plus S2, add them, right?
180 meters.
So that is how you could do it. And from your graph, you're adding t in seconds and velocity in meters per second, right? And area also you could easily figure out. Triangle and trapezoid area you could use. A triangle, right? 4 is very easy. So as I say.
Yeah, so my issue was the understanding the part B. I didn't really understand what they meant. But that's clear now when you look at the sign and then from the deacceleration point, applying the brakes, and in that time. Yeah, for some reason I thought when you brake, it just like I knew time went on. I just didn't realize distance was going as well. That's all. Yeah. Okay.
So yeah, breaking down your question. So we have come to a conclusion which is not the bookish style working. Let me be clear about it. But it is breaking down a question into simpler parts and applying the logic.
Yeah.
Right. We know that default values are A, B, C. But while we are solving the question, we can have values as per our context.
Right.
Let's be real.
Right? Don't just go with it just because it's the method. You have to be realistic into the, like you said, in the context.
In the context. Yeah. Acceleration, we know deceleration right now. Minus. I'll put minus, clear? Yeah. And then I'll use it in my formula, which is as shown here, correct? I will not use two different formulas for acceleration dx. No. I'll use one formula as equals to ut plus half at square. And if it is deacceleration, I'll write minus, correct? Yeah. Simple as that. So that is how we are going to use it. That's really clear, sir. Thank you. But I liked your idea at this stage. You could find area under the curve. Only because it's nice numbers, and plus the graph is pretty accurate. So the area under the curve. Yeah. I would have gone only with the equations this time. Good. Okay. So let's clear this. Any other question? Yes. So so this is question 9. There's an issue. Now we're moving on more to those connected particle questions. Okay, sure. Yeah. Can you please read the question? So a car of mass 900 kg pulls a trailer of mass 300 kg along a straight horizontal road using a light tow bar which is parallel to the road. The horizontal forces to the motion of the car and the trailer have magnitudes 200 and 100 newtons respectively. The engine of the car produces a constant horizontal driving force on the car of magnitude 1,200 newtons. Part A show that the acceleration of the car and trailer is 0.75. Right. So let's make the diagram first. A car of mass 9,000 kg pulls a trailer of mass 300 kg. So okay. So we have this as 900 and 300. Using a light tow bar which is parallel to the road. This tow bar, the horizontal resistance to the motion of the car and the trailer have a magnitude of 200 newtons and 100 newtons respectively. Yep. Car and the trailer. So the friction, well, not friction, but like going the opposite direction. Okay. The engine of the car produces a constant horizontal driving force on the car of magnitude 1200 meters. Correct. Show that the acceleration of the car and the trailer is 0.75. So it is very clear that acceleration is going to be constant, right?
Yeah.
Acceleration is constant. Same for both. Very clear. Now, Newton's law says F equals to ma, right?
Yeah.
So acceleration is due to, the force is due to the mass and acceleration. So when there is a net force, the net force is how much? 1200 minus the going backward force, right?
Yeah. So 200 and 100.
Minus 200 and minus 100. So that is the net force. Remember F net. And mass, net mass is 900 plus 300, right?
Yeah.
Times the acceleration A. Because the whole system is one system and it is moving forward. So from here, we can calculate what acceleration A is, right? So we'll divide all this by 900 plus 300. So what do you get? 1200 minus
So you get
200,
1200.
900.
You get 900 equals 1200 A. So A equals 0.75, like they require.
I think that is what we wanted, right?
Yeah.
Correct. So we get A as equals to 0.75 meters per second square. Perfect. So that is the first part. Now what is the second part?
Find the magnitude of the tension in the tow bar.
So now we want the tension. This is very important at this particular point, right? That is the tension we want, right?
Yeah.
Now remember that the acceleration at this point is still same as 0.75, correct?
Oh, okay.
Right? So at this point, if you analyze, then the system is moving still forward, correct?
Yeah.
And it is going because of the tension. So let's say Ft is the tension, right? Let me write Ft. This is the forward movement. It is, and it has to overcome this 100 Newton also, right? Which is reverse.
Yeah, because it's moving forward, right? So Ft is greater than 100.
Yeah, and that should be equals to ma. Mass is 300, right? Times the acceleration of 0.75. Because F net, again we are using F net equals to ma. Now this time, the mass is 300, acceleration is 0.75, and F net force is the tension minus 100 Newton, which is acting in the reverse direction, friction.
Right. So
and
just quick.
Yes.
Sorry, quick question. So in the tow bar, there's tension this way because it's pulling that way, and then is there also tension in the opposite direction for the car, or is there only tension in one direction? Like, is there opposing tension like this?
Yeah, basically the tension which is moving this in the front direction is Ft.
Yeah. But within the tow bar, is there two tensions?
No, when I broke this away from that previous one, then this is the only force which is acting in the right hand direction. So when I make this block, this particular block, then I have only Ft here. Correct? And I have
100 in the other direction.
This 100 here.
Okay. Right? So if you were to draw the particle just for the 900 one, how would it look? Would tension work in that direction?
Yeah. Then the tension will be backward. Yes.
Oh, okay. So
but that will act backward and this will act like this, so they will cancel.
Yeah. Cool. That's when they're connected. But when you took that out, it became the tension only acting in one direction.
Yeah.
Got it.
It can pull that, moving it, right? So when you do this calculation, what do you get? F tension is So bring this 100, add this 100 to this, 300
Oh, I
is
did it.
0.7
Yeah. 325.
plus 100, right? Add 100.
Yeah.
So what do you get?
325
Right.
newtons.
That is it. So
Cool.
that is how you should be in a position to answer this question. Is that clear to you?
That's clear. Yeah. It's part C, which I didn't understand.
Okay. What is the next part? The car is moving. Continue. The car is moving along the road,
Along the
and the
road.
driver sees a set of traffic lights which have turned red. He reduces the force produced by the engine to 0 and applies the brake. The brakes produce a force on the car of magnitude F newtons, and the car and the trailer deaccelerates. Given that the resistance to motion are unchanged, that means those forces are still acting 300 newtons, right?
100 and 200.
Unchanged. And the magnitude of the thrust in the tow bar is 100 newtons. Find the value of F.
So the main issue with me for this question was when it said a force on the car of magnitude F. What does that mean on the car? Is it working this way or that way or?
Okay, so the car is the 900 kgs, so the net system first car itself, because engine is driving the whole thing, right?
Yeah.
So a car of 900 kg, that means right that engine which is driving, right?
Yeah.
So the situation is kind of similar as far as the two cars are concerned and the trailer, right? So
yeah,
let's say this is your car and this is your trailer, which is 900 and 300, correct?
mm-hmm.
We have a force which is frictional force, which is acting, which remains same, which is 100 and how much? 200, right?
200. Yeah.
That remains same. Now the scenario has changed, that brakes have been applied, and says the car is moving along the road when the driver sees a set of traffic lights have turned red. He reduces the force produced by the engine to 0. So that extra 1200 is gone, and applies brakes. So deceleration. So A is negative, right? So that means deceleration is negative. So it's acting in this direction. Produces a force on the car of magnitude F, and this produces an additional force of F
On the car.
on the system which is connected.
Okay.
Okay. So if this force will be translated, but produces on F, right? So it says what? The brakes produce a force on the car of magnitude F newtons, and the car and the trailer deaccelerates. Okay. Given that the resistance to motion are unchanged, that means 100 and 200, and the magnitude of the thrust in the tow bar is 100. So this Ft is now 100. Find the value of F. Find the value of F. This is the situation. You get the idea?
Yeah.
So, so basically, when, let me say it like this. Let's look into the tow bar portion. This block. Because we are given that now the tension here is 100, right? That. So if you look into this system, let me just make them bigger. So this tension is 100 now, acting in this direction.
Yeah.
And this is also 100 acting here, right? On 300 kg.
But it's working in the opposite direction, 100.
Yeah, because the acceleration is now in this direction, right? So if you look into this system, then F equals to ma, right? Total force is 100 plus 100.
But sir, don't they cancel?
No, when you are acting on one, in between, if both are connected, then they cancel.
No, but like, you know the diagram that you circled with the orange box? 100's working in the forward direction and 100's working in the backward direction. So they cancel.
No. This 100, which is the net, when they say the tow bar is 100 newton, they are saying, given that the resistance to motion are unchanged and the magnitude of thrust Ft is 100.
Which is the forward.
Which is, in this case, like when you apply the brake, action and reaction are equal and opposite. So you get it in the reverse direction. So that is that 100. So both these hundreds are acting in this direction. Do you understand?
Oh.
And that will cause a deceleration on the trailer.
Wait, so the reason it's acting in the opposite is because you're decelerating?
Yes. So 200 is their sum, which is mass into A, ma, and mass is 300 times acceleration A. And therefore, we have 200 over 300 as the acceleration, which is 2 over 3. Now, it is acting in the backward direction. It's a deceleration. But this
so
acceleration,
sorry, it's not minus 2/3, it's just 2/3.
We have taken direction as left, so you can say minus.
Okay.
If you want to use. So it is acting backwards. It's a deceleration of 2/3, which is minus acceleration, right?
Okay. Yeah.
Now, effectively, the whole system is connected, and therefore this deceleration is on the whole system, correct?
Right.
So now looking into the car itself, we have a resistance of 200 here. And on this acceleration of this, the body is still moving forward, but with lower speed because it is deceleration. Correct? So F equals to ma, but in this case, now the acceleration is 2/3 times 900. And what is the force acting on it?
Minus 200 plus F.
We have to find the force F.
Wait, we're taking backwards as positive.
Yeah, backward is positive.
Oh, okay. So then 200 plus F. Wait, 0 minus 200 plus F.
So force F.
No.
Given that the resistance now the force is acting left, friction is acting F, but this tension which was acting now will now be in the forward direction.
Oh, so
force plus 200 minus 100 is equals to mass of 900 times 2/3 acceleration.
Wait, so is the 100 in the tow bar?
Now that is acting as a tension. Yeah. Now it will act in this depth. It will oppose it, right? Yeah.
Okay.
So what do you get? 600 minus 200 plus 100, which is 500. So you get force of 500 newtons. See, I mean, when you make the system, you have to understand that overall the system is moving forward, correct?
Yeah.
Why is it moving forward if all the forces are acting backwards?
All right, so I'll check with teachers.
Yeah, check with teachers. Try to understand this topic. Maybe difficult. I mean.
Okay. Yeah. Slightly tricky. That's what I mean with mechanics. This is quite hard. Yeah, it requires a lot of logical reasoning, but then they give us a set of like rules and methods to work, and then sometimes they won't apply. So I'm just kind of in two heads. So yeah, I guess I'll just do a bit more practice. But thank you so much, sir. The ball questions and the rebounds, you don't know, I've been struggling with that a lot.
Okay, that's fine.
So, yeah, thank you, sir.
Okay, great. So we'll end the class here. At least that part was absolutely clear. Right?
Yeah, very.
So we'll end the class and move forward with more questions in the next class.
Perfect. Thank you so much, sir.
Bye.
I'll see you tomorrow. Thank you, sir. Bye.